Hi there, and welcome back to this XS1100 Trike build with myself, Phil Baker. Just going to show you how to test the Regulator Rectifier, and also I've been pulling the wiring back a bit, the original wiring on the bike. It's still a mess, but it's easier to see what I've been doing, and we'll take it from there. I'll also show you what else needs doing. As you can imagine, it's quite a big project, so let's get on with it. So as you can see, it's still a bit of a mess, but I've actually started separating everything now. Trying to just takes a bit of time and a bit of patience with a capital P, but so as you can see, these are the wires coming up from the alternator. Someone's put spades on in the past, the block must have gone right mess. So that needs sorting out. This is the other two coming from the alternator, or the stator, really, on the bike, as it's called. The stator is a three-phase. You have 3 white cables, which are sending voltage out on each. So there's that to sort out. All the ignition circuit I've put all over to this side now. As you can see those, that's where the coils are going in. Still got the resistor hanging up here, but all this is going to be moving down. This is the actual, this item here. This is the emergency stop, which I was telling you about, which has got black and white coming from the TCI unit, which is down here. I'll show you that. The TCI unit, there's a black and white lead that comes up, has 6 volts running down it, and it goes off to earth via this little unit here. That is basically a ring, copper ring inside. The bike goes over. This is a Trike, so it's not necessarily needed, but I'll keep it in the system. Really, I'd sooner keep it there. If the bike goes over more than 60 degrees, the little copper ring moves along on a bar in there, and it connects with the 6 volts and shorts the ignition off and makes it stop. So the bike's not running if it was on its side. Everything that's here is, I need everything off here for definite. So I've got the sender unit for the tank. This will run back up to the clocks. But this is the sender unit. Then we've got the indicator relays, wiring running to the back of the bike. It will get cut down. It'll all be going into plastic corrugated tubing, or maybe some stainless tubing, depends on what I end up doing with the bike. But if it's just going to run down the centre, it'll be in some corrugated tubing. As these two are for the Regulator Rectifier, which I've actually sits here, which I've actually taken off because I'm going to show you how to test that in a minute. And then that's all the earth points at the moment, running off there. Again, these two from the Regulator Rectifier are running down onto these connectors. Depending on where I end up putting the Regulator Rectifier, which might end up in the electrics box, these might get cut back a little bit and placed in there. I have had a thought about doing that, and the resistor for the ignition, which I've got hanging up here, I was thinking of putting this down in the electrics box. However, I think it has to be reasonably close to the coils. The closer it is to the coils, the better the resistance it's going to be. So I might put the Regulator Rectifier into the electrics box, which I said will be down underneath here, and maybe the resistor might end up sitting where the Regulator Rectifier was, with some form of rubber sleeving over it so that it can't get damaged. I think that might sound like a plan. And then all the rest of it, all we've got here is the rest of the loom, which I've pulled to one side. This is basically, was originally the original ignition, which, as I said, we had a problem with on the ignition switch, which we're going to be ending up putting the ignition switch down near the electrics box, I would have thought, rather than on the front of the bike. So that'll most surely get ditched. I think that's the main headlight one, which is a right mess. I'm sure a lot of this wiring's been melted or something at some stage in the past. They've had some serious problems with this, and I'm hoping that a regulator rectifier, when I test it, is okay, because if it isn't, I'm going to have to buy another one. Then you've got, I think that's the feeds to the clocks. Again, there's a few wires that have been snipped, and that was for the horn. There was a big break in one of the wires. I wondered why, when I run some power through to the horn from the wires, why it didn't work, and that was the reason why. So a lot of this is all going to get cut back. It's all going to get trimmed back. So that's basically that's where I'm up to. But we're now getting to a position where I'm separating the stuff that I really need, and a lot of this side will get ditched at some stage. Okay, so this is a Regulator Rectifier, and on smaller bikes, like dirt bikes and stuff like that, which you don't need, you haven't got any lights and stuff like that on them, they only run a single phase regulator rectifier. You can tell the difference between a single phase and a three phase, because the single phase will only have one connector, whereas the three phase has two. These are the three cables coming off from the stator. I've only put this on this kit with these wires only so that we can do a reading, rather than trying to get down with the pins into there. It's a bit easier. This was off another wire loom I had, which was knackered. So basically, I'll put a drawing up on the site in this particular video, so you can see what the wiring is. But basically, there's a load of diodes in here. We were talking about diodes the other day with the relay that's on the ignition system, and basically the power is coming up from the stator through here into the rectifier. The rectifier then sends it out DC to the red. That is also that's your earth, or the black, I should say. And then you've also got the regulator, which is this side. This basically regulates the power that's going to be going to the system, so it's not, you're not charging the battery too much, and you're not sending too many volts through and starts blowing bulbs and stuff like that in your headlight and your indicators. So that's basically how it works. So basically the diodes inside they're only supposed to run one way. So the idea is we set this to continuity, but set it on DC volts, which you do with that on this one. And what we're going to do is we're going to send power through from this white side on each of the cables. And so you've got your power going on the red lead, and the black lead goes onto the red of the output. We'll test it that way. Then we do a reverse test and send the voltage the other way. If we get any reading coming back up and back down into these, then the rectifier's knackered. So we just connect. If I do this the other way around, you'll be able to see better. So connect the black probe onto the red, and we're getting 0.5 or just over 0.5, which is good. I believe it's supposed to be anything between 0.3 and 0.5 DC volts, so that's fine. And that's on all three, same readings, so that's a good start. So then we swap over and we put the red, so we're now trying to send the power back up the wrong way basically. If we get continuity here, which we haven't, OL is good, OL is good, OL is good. So basically there's no power coming back in, so that's fine. The same again with the black. Try and spin this round so you can see what I'm doing. We connect the red to the black. So you'll be able to see from the diagram that I put up how the diodes, which way the diodes are flowing. And should only be going that way. Then if we swap them round, so basically I'd be sending the power down the white and through to the negative, which is the wrong way. So we don't want any readings there. So it does look like the regular rectifier is in good nick, which is cool. Just thought I'd show you that.